Hey Corey, let's take a look at this one, buddy. Actually, I've employed the crack team of problem solvers here, um, which means I asked my wife, who is also a math teacher, and she she squared me up. So here's what's going on. Um, in this rectangle, we know that we have phi, which I'm just going to use phi. I don't like the lowercase one. I can't draw that. It comes out looking like e, right? But this whole thing is like is phi. And they're telling us the ratio of that is like phi over 1, right? The ratio of the long side to the short side. Okay? So the long side is phi, the short side is 1. And in this square, basically, I know that all these sides are 1 right here, and I know that this side over here is 1. Okay? So that's cool. This part right here, from here to here now, we can model this. This is going to be phi minus 1. Okay, so our first part here, writing that as a fractional expression or writing it as a ratio, that's going to give us, so for part A, and in the book, the book tells us that it should be like phi minus 1, but I think it should be 1 over phi minus 1, at least to me, right? That gives us the ratio of the long side to the short side. And again, if I look at this triangle, the long side is 1, right? The long side is 1. That's what it's telling us. So again, that's kind of my take on that. Feel free to disagree. I think they got the answers a little mixed up here on this one. Eraser, please. Thank you. Okay, so I think that's part A, 1. Now part B, what they want us to do is they want us to set that equal to the original ratio, which was phi over 1. So when we set that equal and we do some cross multiplying, basically here we're going to get phi times phi minus 1, and that equals 1, right? Just cross multiplying here. I'm going to make some more room. Please bear with me. All right. Okay, so now if I do some distribution here, get my pen working again, distribute that, I'm going to get phi squared minus phi equals 1. That's a terrible phi. Like so. Okay, and now basically we could just rearrange this again. I can move this 1 over here by subtracting. So that's going to give us phi squared, or x squared if you want to think of it like that, minus 1 equals 0. So basically A, if we're going to use the quadratic here, A is 1, B equals negative 1, and C equals negative 1. Then we do the quadratic formula, which is what they want. Remember, that's like negative b plus or minus the square root of b squared minus 4ac over 2a. And if you do that, it should come out to be in simplified radical form. It's going to be 1 minus root 5 over 2, and it's going to be 1 plus root 5 over 2. So that's going to be our solutions right there. And in fact, if you graph this out, this is kind of what was my hint, because I didn't do any of this at first. I was trying to graph it and look for an answer that way. So if you graph it out, I just took our little trinomial here when it was set equal to 0, graphed it out. Now you get two x-intercepts, of course. I'm just going to disregard the negative one right now, but look at that, 1.618, which is phi to 3 digits. Okay, so apparently that's a thing, and it pops up everywhere. If you check out that other video on the golden ratio, it's pretty neat. Phi is like all around us. So that's part C, right? So if you wanted to solve any golden ratio rectangle problem, that's the ratio, 1.618 to 1, right? That gives us the ratio of the long side to the short side. So good question, buddy. Hope that helps. You stretched me out on that one, but let me know if this doesn't help or if it does help. Anyway, none of this is on the test. This is just pure geekery, but very enjoyable geekery. Thank you for that.